foundational theory of GPR, and then we moved into our individual 2D processes. We went through most of the processes in the processing pane yesterday, starting with horizontal scaling, distance normalization, and surface normalization, and then moving into processes like edit block, and then the most commonly used processes, which include time zero, our filters, IIR, FIR, background, and noise band, as well as the gain options at our disposal, and migration. We're going to be using a lot of those later processes as we start to explore 3D grids today. So I'm going to show you quite a few 3D grids assembled in a variety of ways. We're going to start with a pre-assembled grid. So this is a grid that was collected on specifically the SIR 3000, but this could be collected on a SIR 3000, a SIR 4000, a Structure Scan Mini or Mini XT, using one of their Scan 3D or Quick 3D data collection modes. So this is where you tell the control unit, I am collecting a 3D grid. It is going to be of this size. It's going to be made up of this many profiles. The profiles are spaced so far apart. And then it guides you through the collection process. Once that data collection is complete, you will have a blueprint file, one of those B3Ds or BZX files that I mentioned yesterday morning. So what we're going to do today is we're going to first point to that folder, our source directory. We're going to select that blueprint file, which tells RADAN this grid is made up of these profiles, which all also exist in the same folder. RADAN will grab those, it will assemble it together, and then we'll be able to process the entire grid and view the post-processed grid and start making interpretations off of what we're seeing. So, few key points here, right? When we're building a 3D grid on the control unit, and we transfer that grid off of the control unit, we will have a folder. This folder contains files. The individual transects will all be their own file. So that'll be file 1, 2, 3, 4, all being made up into one 3D grid. And then we'll also have an additional file. This is that special blueprint file that I pointed out yesterday morning. And that file needs to be with all of the other files. So it's important that they all stay together in the same place on your computer so that when you show RADAN the blueprint, the materials to build it are there also. This might also make more sense when we see it. So if it's still not entirely clear, why don't we just get down to it? So if you haven't yet, please open the RADAN 7 software so that you see the screen similar to myself. Over on the right-hand side of your screen, you may already have the global settings pane. If you don't, head over to the home ribbon up here and make sure that global settings is highlighted. You can click on it once to deselect it, click on it again to make sure that it's there. You should see this pane over here on the right-hand side. This is the global settings pane. It is very important to keep an eye on it while you process data. We did not need to change it yesterday, but we will be changing it quite a few times today as we build our different grids. All right. So we're going to head over here to the source directory. So please double click on the term source directory. It may open up the same source directory we were in yesterday, the GSSI sample data folder. This time we're going to head down to one of these other folders in here. Specifically, we're going to the new PIT 3D grid folder. So please double click on that now. Inside the new PIT folder, there's a grid 1 folder. This is the folder that actually contains the raw materials, the individual DZT files, as well as the build 3D file that we'll use to build this grid. Now, you likely don't have a folder in here called proc. I do because I've already processed this grid a little bit, but you will have this folder after we start opening and processing the grid out. So at this point, just make sure that you're highlighting the grid1.3ds folder in the new pit 3D grid folder, and then click OK. All right, so we've now told RADAN where to look. Because we're using a pre-assembled 3D grid, this part does not matter at this time. But I'm pointing it out now because when we assemble it in RADAN, it's very important that after we set our source directory, that we take a look at the very least, the horizontal units and set them the way that we have our grid notes, right? So by that, I mean, when we're building a grid in RADAN, we're going to need to know the extents of the grid. How long is the x-axis? How long is the y-axis? How far apart is each profile? And we're going to know those in some form of units. We might know that in feet. We might know that in inches. We might know that in meters or centimeters. So we want to make sure that the horizontal units are in those units. But right now it doesn't matter because RADAN's going to build it itself, and we can change this after the fact if we want. So at this time, we've set our source directory. We've done all the preliminary stuff we need to do. So all that's left is to open the grid. We're going to head over here to the home ribbon, and then we're going to click on open. You'll see all of the individual DZT files here. And then I'm going to scroll down to the bottom. Mine's all the way at the bottom. Yours might be up top, depends on how you're sorting. But you should see a grid1 B3D file at the very bottom. Again, I've already opened this, so I also have a grid1 DZT and a grid1 M3D. You won't have these until you open the grid. So you should see, files 1 to 62, and at the very end, a grid1 B3D file. This is the one that we're going to open. So by opening this file, it's going to tell RADAN that this grid1, is made up of these 62 files. It's going to grab these files, put them in the right order, and then show us the result. So let's highlight it and then click open. You can also double click on grid1 to get the same result. Okay, so after a few seconds, the grid opens and we are now looking at one profile in the entire 3D grid. So you might be asking yourself, hey, we built a grid. That grid is made up of 62 files. Where are the rest of them? I'm only seeing one at this time. Well, there are a couple things that are different here in this view than the previous views we were working with. First off, if you look at the top of the tab, it doesn't just say file 1, file 2, file 3. It says grid 001. So this tab does contain the entire grid. If I go down on my file, I see that the file at the very bottom, this bottom bar down here, the file equals is now blank. The distance is still updating, the scan is still updating, the Z is still updating, but I also have an X and a Y coordinate that change. These are the local X and Y coordinates of this grid. I'm also going to change my units right now because I'm realizing that horizontally I'm in feet and vertically I'm in meters. And while it's fine, there's nothing inherently wrong with that. It might be a little confusing. So I'm pretty sure this is an English grid. So we're going to do feet and feet. And just for full disclosure, I just went over here to view and I switched my vertical units to the one that I wanted. You can also do the same for your horizontal as well. So then I'm going to head back over to home, and still doesn't change the fact that I'm just looking at one file. I'm not looking at all 62. Well, in this current view, in order to scroll through and view the other files, you're going to want to go all the way down to this bottom left-hand corner. Down here, you have this new area. It says L001, and there is a left and right arrow. We're going to click the right arrow to bring ourselves over to file 2, file 3, file 4, file 5, and so on and so forth. This is where we go to scroll through our 3D grid and view all of the other profiles. And if we move our mouse up, we'll see that the X and Y value change as we go to each one. Now Y equals 22 feet. Now Y equals 23 feet. Now Y equals 24 feet. So it looks like these profiles are spaced 1 foot apart, going up the Y axis. Some other things you may want to adjust off of yesterday. Most likely you're looking at your grid using the same color table and color transform that you were working in yesterday. If you'd like to change it, you can by heading up to the color tables pane and the color X forms pane. Remember, yesterday I recommended if you're doing some processing in RADAN, especially the processes we're going to do to this grid, I'd recommend not using a grayscale table. If you like grayscale and you want to keep it similar, dirt is a really good option. It allows us to do migration much more easily because that hyperbola fitting tool is difficult to see with the grayscale table. But dirt is a good option. If any of these like lower mid 20s are good options. They go from one color to one other color, so they're all pretty good. And then for color X forms, this is a soils data set, so LM12 or LM8 would be good options for you. LM4 actually looks really good here, so I'm going to stick with LM4. I don't usually use it for soils, but in this grid, it appears to work pretty well. Everything's bright, easy to see, but not too bright, in my opinion. So we'll make some adjustments to this after the fact anyway, so I may actually just switch this back to LM8 because I think we're going to do a new time variable gain anyway. The bottom half of this grid looks a little fainter than I'd want it to be. This whole area is pretty muted. So I think another range gain on top of this can help. If you're scrolling through the grid and you're paying close attention, you might notice that in some of these files, we have a fair amount of static banding at the bottom of the screen. This is cell phone interference. These very discrete static bands are pretty classic cellular interference. Most likely whoever was collecting this grid was taking a call or receiving texts or whatnot at the same time. So this particular antenna, you will often see this a lot. Not a lot, but you'll see it here and there. Most of these files are pretty clean, but a couple of these have, like right over here, file 13 has a couple bands as well. So if you pay close attention to the bottom, you'll see it here and there. Okay. A couple of other different things that are going to be helpful to us here. So with this grid open, we have access to our data windows. We had access to these yesterday as well, but most of these aren't too helpful for individual files. But there are a couple of data windows here that you'll find helpful for 3D. You're going to be really tempted to click 3D view. Please don't just yet. We need to get this a little bit ready for a good 3D view. You can click on it if you want, but it's not going to look too great, and you'll have a lot more functions that'll be really confusing. So we will get here. But line scan is the default view. Line scan is our term for this viewpoint here. You can toggle a scope data window, which is the O-scope view. This scope will update if you click and drag through your file. So if you like working with the O-scope, you can always get that on the screen here in RADAN. If you update your scope to something you want to stay with, you can click and drag and update your scope over here, and then move your mouse over here and click and drag and move freely without worrying about updating this scan. So these data windows are independent of one another. There's an accessory data window. I'm just going to click on it to show you where it is. The accessory data window is down here. This is where you're going to see your line track data. So if you collected data with a utility scan or a structure scan mini XT and you have the line track and you have that DZA file with your line track data, when you click on the accessory data window, you'll see your line track data down here. I'm going to toggle the scope off. Depth pane's not really pertinent here, but the last one I wanted to show you is location. So location is a data window that's particularly helpful when you're looking at 3D grids. When you click on location, it shows you a green gridded area. You can use the scroll wheel on your mouse, if you have one, to zoom out or zoom in. I usually zoom out a little bit because it brings me a little too close to the grid. And then I can click and drag and move this around. So why did I have you put this up here? This is a representation of where all of your individual profiles are. So if I head over to the middle of the grid, right, and I'm looking at line 10, and I'm trying to picture in my head, moving my mouse around, I see the X and Y coordinate of line 10, and I'm trying to picture where line 10 is in my 3D grid. The location data window makes it so that you don't have to imagine where it is. If you want to try to position this out in your field where you collected your data, you can click and drag on it, and as you move your mouse around, if you look at the location window, you'll see that a crosshair is moving with my mouse, allowing me to more easily position where this data is in the site that I was collecting it. Right, and this will work moving left and right as well as up and down. All right. So the location data window has one additional benefit. We're not going to make use of it at this time, but we will use it for one of the later grids that we assemble. If you collected GPS data with your GPR data, but you did not set up the GPS on your radar, you can still use that data to georeference your grid. Let's say you didn't really have the time to figure out how to set up a GPS on your SIR control unit, but you still wanted to be able to place your grid somewhere. You can collect a GPS data point for the bottom left-hand corner of your grid and the top right-hand corner of your grid. And once you have those two coordinates, you can open this location data window, right-click in the middle, and select GPS coords. And then you can type in latitude and longitude your GPS coordinate for your bottom left-hand corner, so min X, min Y, and your field X and field Y, which is by default the top right corner. So you can type in the corresponding latitude and longitude of each side, hit finish, and that will apply GPS coordinates to the rest of your grid. Okay, so Now that we've taken a look at the location data window and our line scan view, I think we are now at a point where we are ready to process. So we have this grid open in front of us, and we need to get this looking a little nicer before we observe it in 3D. I'm just going to take a look at the file header because we did not collect this grid. So we just want a little bit more information about it. I see it was collected in 2006 with a SIR 3000 at 18 scans per foot using a 400 megahertz antenna, dielectric constant of 8, depth of about 17, almost 18 feet. And thus far, in terms of processing, this slight position correction will always be here. This is referring to the time zero correction. It's not enough because you can see this consistent band down here, like 2 or so feet down. We can also see that there's been a low pass, high pass IIR filter and 4 points of range gain. But that's it. That's all the processing that's been done to this so far. So there's been a little bit of processing, but we're going to do a little bit more to get this looking nicer and ready for 3D. So let's walk through the processes that we need to do here. If we look at this grid, as we browse through it, we can definitely see that the top of it is pushed down pretty far. So this is telling us that one of the first things we'll need to do is correct for time zero. We're going to need to put this band back at the top of the screen. So we'll say that's step 1. Generally, if you see it and you know you need to do it, that should be the first thing that you do. So we're going to do a time zero correction. And then after that, it's a little bit more open-ended. This grid has already had a low pass, high pass filter done to it, so we don't necessarily need to do it. It doesn't really hurt to apply it again, but it's not imperative that we do it. So we can take it or leave it. I think we might just do it for good measure so that we can see that process again. The other thing we might need to do is after we take care of time zero, we'll have some consistent banding at the top of the screen as a result of the direct wave. As you scroll through the file, there really isn't much else in terms of banding. So I would still recommend doing a bandpass removal or noise band removal or background removal filter, one of those filters that gets rid of consistent horizontal banding. That would be worthwhile here just to clean up. There's some subtle banding at the bottom, but we definitely have this band, at least at the top, that we can get rid of to help us see what's hidden in the shallow surface. So after our time zero and high pass, low pass filter, we'll do a background removal or a noise band removal filter. I stated earlier that this area here is a little bit more muted than the rest. If I open up my scope, we can also confirm that in the scope as well. This area of the scope is relatively featureless compared to the rest of the scan, where we can see targets more easily. As we scroll through, we can see that for the most part, it's pretty flat. A little bit more screen contrast here. Maybe it's just that there weren't any targets, but regardless, it's a little fainter down here. So I'm thinking an additional range gain will help us. So we'll do some range gain to brighten it up and make it easier to see. And then lastly, because we're looking at this grid in 3D, the intention is to look at this in 3D. And we have all of these hyperbolas, these bumps and arches on the screen. And the intention is likely to locate where these pipe-like targets are. It would definitely benefit us to do a migration. That should be the last thing that we do. Migration is a very, I don't want to say invasive, but it does greatly change the appearance of the data. So it's usually left as the last process you would do. I usually do migration just before I look at it in 3D. So we'll wrap up with a migration to focus these hyperbolas into dots, and it'll make everything a lot easier to see. So we've looked through our data. We have a rough game plan of how we want to process it. So all that's left to do is to process the grid. So let's start with the first one. We're going to head over. I'm going to close the scope data window because I don't need it anymore. And I guess I don't need the file header as well. So I'll close that as well. And then we can head over to our processes. So I'm going to click on processing, and then I'm going to head over to time zero. In the time zero process, remember we had two methods that we choose from. Manual, where you click and drag and position this at the top of the screen manually. By the correct manual position, it's going to be in the very middle of the first positive peak of the direct wave. The second method is auto peak. That's generally the one that I've been doing. It works pretty well. So I switch the method over to auto. It snaps it to the right position for me, and then I click OK. Now the benefit here is because we've assembled this grid, we don't need to do this to each and every file. We can test this with one file, and after we hit OK, we will scroll through all 62 files, opening a newly processed grid 1 with everything corrected for time zero. Right, and then as I scroll through, line 1, 2, 3, 4, all of them are now corrected for ground surface. So it's saving us a lot of work. Okay, so now that we've done our first process, we're going to move on to the next one. We're going to click on the processing pane, and we got a couple of options here. There's no real, in my opinion, we could do these in either order. I am going to elect to do the IIR first. I usually start at the left and I just work my way to the right. So we'll start with the IIR filter. Remember, IIR and FIR, these are the two places where we can perform our, where we can apply constraints to what the receiver receives. This is what the high pass and low pass filter does. We basically put a fence around the receiver and say, we only want you to see things in this specific frequency range, and everything outside of that range, I want to filter out and remove. You have two options to do this, FIR and IIR, and I would strongly suggest using our IIR filter 100% of the time for this. You will see a very similar result no matter which one you use, but there is a slight risk of a phase shift using the FIR filter. Phase shift meaning the amplitude might shift up or down by a few samples, which can affect the depth accuracy. Not by any really catastrophic amount. We're talking on the order of like a 64th of an inch, but it's still a possibility. With the IR filter here, we're going to set the vertical filter low pass to 800. We'll start off with our default values, our high pass of 100. Remember, this is a 400 megahertz antenna, so we want to take that center frequency, multiply it by 2 to get our low pass, divide it by 4 to get our high pass, and then our number of poles. I recommend setting that to 12. The higher this number is, the more aggressive the filter is. And as I stated yesterday, I don't really see much of a change after 12, so usually 12 is as high as I go. I'm looking at the scan briefly just to see if I can see any moments where the scan wiggles back and forth and remains on the left or right-hand side. if you notice anything like that in your scan here, you can click and drag to update it too, just to make sure that everything's okay. And if you see any moments where there actually is a moment where it's acting funny, like right over here, if you see anything like that, and a little bit up here too, if you see anything like that, that could be indicative of low frequency interference affecting the wave. And you can help take care of that with a higher high pass filter value. So we'll try 150 just to see if that cleans it up. And it shifted it a tiny amount, not really by any noticeable degree. 200's messing it up even more. So I think I'm just going to keep it at 100, or maybe 150. Be a little bit more aggressive, but not too aggressive. You can see as we make changes to the high pass filter value that the scan does shift a little bit every time you change this number. You can kind of see how I'm working this. I don't want to go much higher than 200, and you won't notice much of a change when you flip it by like 25 or 50 at a time. So I like working in fives if I can. No particular reason. Yeah, and it all looks more or less the same. So I don't think we're going to get much better than this. I'll try a slightly more aggressive high pass filter of 150, and I'll just call that as good as we're going to get. So low pass, we're keeping it the same. High pass, I'm increasing that to 150. Number of poles, we're setting that to 12. And then I'm hitting apply just to make sure I like the way it looks. You're probably not going to see much of a change, and that's okay. This filter's already been done to some degree to this grid, so we shouldn't see a very dramatic change here. But it doesn't hurt to apply it a couple of times, so that's why we're doing it again. And then I'm going to hit OK. It's going to go through our entire grid again and give us a new processed grid at the end. As we were slicing through, I did see a lot of consistent banding at the bottom of the screen, so it's definitely going to be worthwhile to perform one of these background removal or noise band removal filters. I stated yesterday, I'm a really big fan of the noise band removal filter. Most of the time it works the same as background removal, but I like it because it can skip over hyperbolas, keeping their strength intact. Remember, this is a filter that goes through and removes any consistent horizontal bands from our data. And if any of those bands happen to intersect a hyperbola and you use the default background removal filter, it can actually weaken the strength of that hyperbola where the band intersects it. Not by any real catastrophic amount, but it might make it look a little strange. So noise band removal has the ability to recognize that, hey, this is not a band, this is a hyperbola. I'm going to skip around this and keep its strength intact. Default algorithm is fine. You can hit apply just to see how it looks. Gets rid of the banding down here as well as up here. So all good on our front. I'll hit OK. It's going to slice through this and give us a newly processed grid at the end. So at this point, we are 3/5 of the way there. We've done our time zero correction. We've done our IIR low pass and high pass filtering. We've done our background removal filter, or noise band removal, rather. So next, it would be helpful to try range gain. maybe just a little bit more screen contrast to help us out, or what we should probably rather do is perform a gain restoration first. Gain restoration will remove all of the time variable gain from this so that we are building it from scratch. Generally, that's a better idea when you're performing a gain correction. So I'm going to head over to my color X forms. I'm on LM8, which is where I wanted to be. So just wanted to make sure I wasn't working at LM4 still. And then I'm going to head over to processing, and we're going to start with a gain restoration. Hit OK. It's going to make everything look way worse. If that's okay, we're going to come through and fix it. All right, so everything's really bright at the top and it's pretty faint everywhere else, but that's okay. Now's our turn to go through and make everything look better. So we're going to head over here to range gain next. We're going to switch the gain type from automatic to exponential. We have the option of applying up to 16 points. And remember, the sweet spot for this, in my opinion, is somewhere between 7 and 10. I just keep hitting the up arrow until I think I have enough points. No real science behind it. I just look until I see I have enough. And 8 or 9 is fine. I'm going to stick with 8 this time. So I have 8 points set. The first 2 points are a little counterintuitive. The first one, you usually want to drag it a little bit to the right. Anywhere between like 3 and -5 is fine. You just want a little bit less gain at the top where it's particularly bright, and then a little bit more gain afterwards. That already looks pretty good, so probably won't do much more than that. And then I'll click and drag, move this over, start applying even more gain. And then remember, you have to click and drag and move this all the way over. And then when you let go, this number will double and you can do it more and more and more. That's going to be way too much. So we'll hit apply and see how this looks. Okay, so maybe a little too much at the top. That's a little brighter than I'd want to be. So I'll hit reset. Everything else looked pretty good, but that was maybe a little much. So looks okay. We'll head over. So we have 62 files in here too. So it's important that when we set our range gain, that we make sure that this works well everywhere, not just on the one file we're testing this on. It's definitely good to hit apply, reset on a couple files to make sure that the curve that you're building works well everywhere. Remember, don't do too many at a time too. Usually 1 or 2 is all you need. And then scroll through, look at a few of them. Make sure that what you're doing, again, works well everywhere. Ooh, it's a little too much. I think we more or less ended with the same result. Yeah, might be as good as we get. Okay, so without a range gain, it works fine. I think this area is a little too varied to get a good range gain everywhere, but it's good enough for us to see the targets we want to see. So we'll hit OK once we're happy with it. It'll apply this range gain curve to all of our files and give us a newly processed grid at the end. So now that we've built the entire grid and we've processed through most of it, we've gotten rid of most of the noise and interference, we've brightened it up, all that's really left for us to do is to migrate. We have a number of hyperbolas on the screen, and all we really need to do at this point now is set our dielectric constant with a migration. So I'm just going to scroll through to a file that has a fairly deep hyperbola. This isn't the deepest one, but it's one of the deeper ones I was able to find. And in general, that would be a good place to migrate with. You want to try to pick the deepest target in your grid, or at the very least, the deepest target at the depth you are interested in, so that when you calculate your dielectric constant through this process, you have the best average constant down to that depth, right? That's the key here. So this is one of the deepest ones I could find. This will get me the best average dielectric constant down to this depth, which means the depths of my targets above this should all be fairly accurate as well. So I'm going to head over to processing. I'm going to select migration. It's going to bring the tool up on the screen, and we're going to fit this tool over the target that we see. So again, you have these three boxes here. I'm going to click. I usually just use this top box. The side boxes are kind of hard to work with, so I generally just work with the top one. I fit this arch here. And then don't forget the vertical bars as well. You want to drag those roughly to the edges of the visible tails of the hyperbola. We have a lot of numbers over here, but remember the only one we need to be concerned with is the dielectric constant. I also mentioned that once you have this set, I sometimes like to add some additional gain because this process does weaken everything by a fair amount. But if you forget this, don't worry. You can get the same result by just adding some display gain afterwards. These are the same gain. So dielectric is the one number we're looking at here. I'm going to hit apply to see how we did, and we did pretty well. These look great. The upper ones look great. These are slightly curving down. These are slightly curving up. Curving up means the dielectric needs to go up. Curving down means the dielectric needs to go down. But for the most part, that might actually be as good as we're going to get. Maybe we'll just go up a little bit. We'll make it a clean 18. Hit apply. And that looks pretty good. So this is, again, like range gain, something that's going to happen to all 62 files. So you want to make sure that this will work well on most of your grid, as many files as you can look at. It's not going to be perfect for all of them. It's going to migrate the hyperbolas that you cross at a roughly 90-degree angle fairly well. But there are some targets here that we crossed at a 45 or at some other angle, like this one here, for example. As we scroll through, you see that it actually moves to the left if I go this way, and it moves to the right if I go this way. It's telling me that it's a little diagonal, and when I hit apply, it's not going to migrate that pretty well because that hyperbola is much broader than what this process is expecting. But for the most part, it does a pretty good job. So I think this is a good number for us to migrate with. Yeah. So I will hit the OK button to run this process through the grid. All right, and now we have our fully processed 3D grid. So we've done our migration, we've done our range gain, we've done our other filtration processes. So all that's left for us to do now is look at our grid in 3D. So we can head up to the home ribbon and we can click on the 3D view data window. All right. So I'm going to close some of these other windows just to give us some more space to work with. I'm going to close this processes other window, which is this pane over here, because we're not going to need it at this point. I'm also going to close window settings. That is helpful for 3D grids, but actually I'll leave it up. So we have our 2D data open over here. We have our 3D data over here. I'm just going to make this a little bit smaller. And then we have our grid in the middle. If you click and drag and start moving your grid around, you'll see a couple of things happen. One, the grid's going to move. It's going to move with your mouse as you click and drag. You're also going to see that this 3D volume options pane becomes selectable. So this is a new pane that opens up when you open up a 3D data window. This pane allows us to make adjustments to the grid that we have open and observe those changes in the grid. So we're scrolling around. We can see that we have some walls. These walls correspond to our X profiles and our Y profiles. The profiles then went up and down along the Y-axis, and that went left and right along the X-axis. We also have this Z-slice representation of the grid that we collected. If you want to move any of these, you can do that with the buttons up here or the buttons here. So this is moving the Y slice. This is moving the Z slice. And this is moving the X slice. You can animate the slices by clicking on the animation button. The slice will start animating. Once it's started to animate, you can actually use your keyboard to speed it up or slow it down. You can press the up arrow on your keyboard to speed it up and the down arrow to slow it down. If you click on the animation button again, it should stop. What you can also do, if you want to move your slices on your own, you can use these buttons, of course, but what I prefer to do is to use my keyboard and mouse. If you hold either of the control keys on your keyboard, so the CRTL key, you can click and drag on your slice to move it with your mouse. So again, hold the control key on your keyboard and then click and drag on your slice to move it up and down. All right. So some other things that we can do here. If you look over on the left-hand side of your ribbon, you'll see that there is a 3D slice controls area. 3D slice controls allows you to adjust your X, Y, or Z profiles. You can actually stretch or compress them depending on which axis you're clicking on. So I'm going to click on Z to highlight Z. This is something that I usually do right after I open up a grid is I highlight the Z slice and then I stretch it by clicking on this pink button. So I'm stretching it along the Z axis. With 3D slice controls, if you click on the Z slice, right, I'm stretching and compressing by clicking on these pink buttons here. You can also do the same with the X and Y buttons. So if you click on X and Y and slice or stretch or compress, that works as well. You can also do all of this with your keyboard. If you hold the X, Y, and Z key on your keyboard, you can hold those buttons down and then press the up or down arrow key. So for example, I'm going to hold the Z key on my keyboard, and with the Z key held down, I'm going to also press the up arrow key. I pressed it a few times, and that stretches the cube on the Z axis. I can also do the same with the X axis and the Y axis. So if you get carried away and you no longer know where your grid is, or your grid suddenly looks really funky, like mine does, that's okay. You can always fix it with the last button here, this viewpoint reset button. If you click on that, it will switch your grid back to normal, giving you a nice place to start off again. But usually what I do is after I open the grid, I just stretch the Z-slice out a little bit because it's easy to forget, you know, this 3D grid looks really nice. It's really easy to see our targets in this 3D view, but this grid is made up of the 2D profiles. These are the files that we really collected. So when you're making your interpretations, it's important not to forget that, yes, I see this pipe here very clearly. I right-clicked on my data and I added some display gain to make it even brighter. But this pipe is easy for me to see, but I also want to confirm that I see it over here. And I am seeing, yes, this line intersects with this dot rather is intersecting with this as I slice through it. So that's telling me, you know, where my target is. Right. I also see that, you know, we have some big thing here that's ringing down, and if I look over, I can see that, yes, that big thing is right there. It's very clear, well defined. I got another one over here. Let's look at the data to confirm. And yeah, I can see another feature here, another bright feature, which I'm also seeing in my profile over here. So confirming what you're seeing in the Z-slice with what you see in the X and Y profiles is very, very important because these are the real profiles that we collected. And it just helps to confirm what you're seeing on the screen. Okay. So we've talked about how to adjust our slices. We've talked about how to move the slices around. You can also do a lot of this over here in the Windows settings pane. If you don't have it open, just click on Windows settings. Windows settings, when your 2D data is selected, is very simple. When your 3D data is selected, you have a lot more options. This is also where you can go if you want to just type in a specific Z position. Maybe I want to see everything exactly at 3 feet. I can just type in 3, and that'll snap me right to 3 feet. This Z slice does have a thickness associated with it. The thickness is currently set to 0.94 feet, so we'll round it and just say a foot. And that means that this Z-slice is showing me everything a half a foot above and a half a foot below its current depth. So if it's positioned at 3 feet and its thickness is roughly 1 foot, we'll just say it's 1 foot exactly. Type in 1. That means that I'm seeing everything from 2.5 to 3.5 feet. We have a couple of other things that we can do over here in the Windows settings pane that we'll touch on as we get through the class. But for now, I wanted to show you how to draw targets in your grid. So to draw targets in here, if you see a pipe-like target on your screen, which I do right over here, I can head up to the 3D volume options, 3D interactive, 3D free draw tool. So I can select free draw. I can go down to my target and I can double click on one end of the target. When you double click on it very quickly, you'll see a dot show up on your screen. I can go over to the other end, double click the other end, and RADAN will connect the dots. So we've now drawn a pipe into our grid. Some notes on this. When you double click, the point will lock itself to the highest amplitude it can find in a search radius. So sometimes the dot might snap above the slice. Sometimes the dot shows up below the slice, especially if your slice is particularly thick. So if you double click and you don't see anything, sometimes I find that I have to look underneath here and I'll see the dot underneath the slice. And there might be quite a few if you've been double clicking a lot. So just after you double click, if you don't see anything immediately happen, just look underneath your slice and see if it's hidden underneath there. It's rare that happens, but it's happened to me before. But we have a pipe here now. If we want to draw a new pipe in, we can either click on new target or we can right click and select new target. And then I'm going to head over here, double click to draw in a new target. Maybe I want to differentiate these. So if I want to change it up, I can right click on it. I can delete it if I added it incorrectly, or I can go to target properties. I can change the name. I can change the color. I can change the diameter. I can go up to new target if I want to draw in a new one. Double click. And as long as you keep double clicking, it's going to keep connecting the dots. So you can do that as much as you want. You can slice your grid down and add in angle targets. So all very doable. As I'm sure you saw also, if you right click on your data, there is also a drill hole function. So after you finish drawing in your targets, if you want to try to clear an area for a concrete core or a dig in general, you can specify a drill hole of a specific diameter or type in a custom diameter, and it'll put a green hole straight down through your grid. So if you right click on the target and select delete, it will delete everything. If you want to delete individual dots, the only way to do that is to do it through the tables pane. So if you head back to home, you'll see that the tables other window contains tables of information that we were working with yesterday. And now that we have 3D free draw selected, we have these new tables over here. One of them free draw groups. So these are the whole targets that I can display, change, and whatnot. But you can also, let's not do yellow, that's way too bright. You can also do free draw points. So pipe 2 is this one here, and if I wanted to delete maybe this one here, I can right click on it and say delete. Usually you have to do it twice, I found. The first time you click it, nothing happens, and then the second time you can delete your point. And then you should be able to do one at a time from there on out. So while we're here and we have some drawn targets, let's say that our intention is to export this out to use in other software packages. If you have drawn targets, you can look all the way over on the right-hand side of the 3D volume options ribbon and see that there are different CAD exports at your disposal. You can export the local X, Y, and Z position of your targets into a DXF document. So if you work with DXF, this is one way to get this data out into AutoCAD. If you'd rather just have a picture for your reports, you can click on JPEG to export a picture of this to use in your report. You can also click on the Excel button, and that is our automatic report generator. So if you have Excel or an Excel-like program, you can click on this. You can fill out details about your project or report. And then if you click the OK button, RADAN will open a prefabricated report in Excel showing you the information that you had input. So I'm just going to flip my screen over to that so that you can see it. So ground penetrating radar investigation report, the name, when it was collected, the picture, and then this would have information if you had typed anything in there. Now that we've gotten to the end of our first pre-assembled 3D grid, we are now going to build a grid from scratch. There are a couple of different ways to do this in RADAN, and we're going to cover the 3 methods at our disposal today. The first method we're going to look at is using 3D batch of files. 3D batch of files is an assembly function that's ideal for building simple 3D grids. These are square or rectangular areas with no real obstacles in the way. 3D batch of files allows you to quickly build that grid up. You just tell it the dimensions of the grid, add the lines, the profile spacing is determined by the function automatically, and then you have the ability to then add GPS coordinates at the end if you have them. If you don't do it at that step, that's okay. We did also see that we could add GPS points at any time in this location data window here. The window looks the same no matter where you do it, but this is where we're going to start our 3D assembly. We're going to start with 3D batch of files. So before we get there, we need to close all of the grids that we currently have open. We can't have any data open to assemble a grid. We saw this yesterday when we tried to append files together as well. When we split strats into 2 halves and then we appended it into a new file. The same is true for 3D grids. We can't have anything open to do this assembly. So a quick way to close everything is to just head up to the main button here and then select Close All Open Files. Now that we're on our main RADAN screen, we can head over to Global Settings, to the source directory, and this time we are going to go to a new folder. We're going to head up to the Grids and GPS folder. We're going to head into the ManchesterCC folder. And we're going to open the 12th hole. Again, you're not going to see this proc folder here. I have it because I've already processed this grid. So all you should have down here is the 12th hole in the ManchesterCC folder in the Grids and GPS folder. So make sure that that 12th hole folder is highlighted in the grids and GPS folder, and then click OK. So inside each of these grid folders, we do have notes about the grid that specify the dimensions, how far apart the profiles are, how many profiles there are. Just bear with me for a second. I'm going to open that up. You don't need to open it. I can tell you the relevant information there, but if you want to, you can head into that 12th hole folder outside of RADAN, and there should be a PDF document. It's either a PDF, sometimes it's a doc, but some file that says parameters. Okay. And so with the parameters file open, I can see that this is a grid that was collected in English units. It's important to know that because I want to then go down here after I update my source directory and make sure that my horizontal units, at the very least, are also in English units. Specifically, they should be in feet. I have feet selected as my horizontal units. I also like to make sure that my vertical units are set the same, but that's less important. All that's really important here is that our horizontal units are correct. And the primary reason for this is we're going to have to type in the dimensions of our grid. And I have those notes in feet. I'd rather not do the conversion to some other unit, so I'm switching my horizontal units to feet. So I switch that there. Vertical units is fine, source directory is fine, so we are now set and ready to go. We can head up to the G button, assemble data file, and we are going to do a 3D batch of files. All right, so on this first window here, it just wants us to give the batch a name. So this is going to be the name of our grid. We can call this anything we want. I will call this a name that I haven't given it yet. I will call it my grid. Then hit next. We can add any of the available files in this folder, and we want to add all of them. So we can click Add All. It will add them all over here. And now at this point, the order of the files may or may not matter. In our case here, where all of the data went in one direction, we did it says bidirectional on the notes, but this was actually a unidirectional grid. So everything was collected moving up and down along the y-axis. In that case, where all of our data went up and down along one axis, this order does matter. Because we're not going to get a chance to reorganize these files later on in the assembly. So if you only collected data moving up and down along one direction, make sure that these files are in the order that they should be stitched together. So in our case, we collected it in ascending order. So the lowest numbered file name should be the first file, and the highest numbered should be the last file. So we don't need to do any reorganizing here. But if your notes specify something else, then you'll want to reorganize these before you hit next. If you instead collected data in two directions, you collected up and down along Y and left and right along X, then this order does not matter at this time. You'll have the ability to reorganize it later on when you specify which files went in the X direction and which files went in the Y direction. So everything over here is in order. We hit add all, so we can just hit next. And now this is where we specify the dimensions of the grid. Min X and min Y are almost always going to be 0, so we can leave those set to 0. Max X, looking at our notes, is 80 feet. Max Y, looking at our notes, is 100 feet. So this is an 80 by 100 foot grid. And then in section 2, checking which direction we moved in, we only went up and down along the y-axis. So just check that middle box there. And then hit next. Everything in here we can leave set to the default, with the exception of the order. This one up here, we're going to use the entire 3D display area selected earlier. I've never changed this, but if for some reason you collected data in a different area than you specified earlier, you can specify that different area down here. That might be true if maybe you couldn't do the whole grid in the Y direction, but you could in the X direction. You could specify that here, but I've never found myself in a situation where I needed to do that. So just use the default up here. Down here, if we look at our notes, we see that this is a zigzag data collection, which means we started in the bottom left-hand corner. That's what this box specifies, but we didn't always collect data from south to north. We collected in zigzags. So I want to click on this. I want to scroll down until I find a picture that represents what I did. This is the right one for us, where the small black box is still in the bottom left-hand corner, but now I'm collecting up and then down and then up and then down. This looks good. This looks good. We can hit next. We can quickly look over the dimensions of our profiles here to see if they all check out. The second one is a lot longer than the rest, but that's okay. That was just an issue with the survey wheel. Everything else is roughly 100 feet long. They're all spaced 2 feet apart, as our notes say, so everything looks to be in good shape. We'll hit next, and on this last window, we do have the option of adding GPS coordinates. If you want to add them, they are in the folder. I will stay here for a couple minutes. I'll add the GPS coordinates in, and if you just want to type in what I put there, feel free to. It's okay if you don't. It's not imperative for us to do this, but if you want to start looking at some GPS data, this might be a good exercise for you. So I'm going to click on Enter GPS Coordinates, and then I'm going to head down here, and if you go to the Grids and GPS folder, and then go into the ManchesterCC folder, you'll see an Excel doc. I'm going to hit Finish at this point. And so at this point, we have assembled our grid. And if you added the latitude and longitude, you'll also see at the very bottom that we have a lat and long as we scroll through. Something else you'll see is when we've opened this grid, it's opened not just once, but twice. We have a My Grid. In my case, I call it My Grid. So I have a tab that says My Grid. And then next to it, I have a My Grid P_1. For anybody with a current generation system like the SIR 4000 or Utility Scan or SIR 30 or Structure Scan Mini, when you open data collected with one of those systems, you're going to get two tabs. The first tab is the completely unprocessed data. So this is the raw GPR data without any high-pass, low-pass filters, without any range gain, without anything that we might have done on the control unit to improve the image. So completely unprocessed. The second time the grid opens, it's pre-processed with anything that we did on the control unit already applied. This gives us two paths to go down. We can continue processing the pre-processed grid to make it look a little nicer prior to observing it in 3D. Or if we did some stuff in the field that we kind of regret or that we would rather redo in RADAN, we can always go back to the raw file and start it from scratch. Because we're here in an advanced data processing class, we're going to do the raw grid. So we're going to start with the first tab and not the second one. But just to maybe note that down, when you assemble grids using 3D batch of files and you have DZT and DZX files, which is what you get by default from our current generation systems, you will get this two grid setup at the end where you can view the raw one and the pre-processed one. For the other assembly function we'll talk about later, 3D file assembly, we will only get the raw version of the grid. We will not see the pre-processed version. I'm over here, I'm looking at my P_1 version. We're not going to use this one today. We're going to use just the my grid version over here. Feel free to make some changes to your color table and color transform if you need to. I'm still using color table 18. I'm using color XForm 8, which looks pretty good to me. So at this point, we are okay to continue. You will also notice that this grid has had time zero taken care of it already. Ground surface seems to be locked to the top of the screen. That's going to be the case if you're using a current generation system. So the time zero process is usually not one you're going to do if you're using any of our current stuff. But as we scroll through this grid, we're just examining it to see what we should likely do. If we're starting with the raw unprocessed grid, we're going to need to do everything to it. So we're going to follow more or less the same processing flow that we did earlier, where we went through with our IIR filter first. Then we took a look at background removal, mainly to just get rid of this up here. And then we'll look at range gain and migration. The intention for this grid, which can help guide our processing, the intention for this grid was to locate not these pipe-like targets and features, but to locate a layer, an old layer that we expected to see somewhere in the middle of this grid. So the primary goal was for a layer examination, but we do have some hyperbolas in there. So while it's not imperative for us to migrate, because we have these hyperbolas, we may as well to get a more accurate dielectric and to clean up those utilities. So I am going to go through and slowly process this grid. I'm just going to slowly go through this for the next few minutes. I encourage you to do the same. So I should have also mentioned this is a grid that was collected with not a 400 megahertz antenna, but something with a similar center frequency. If you head into the file header, you'll see that the antenna type is pretty weird. It says D400HS. This is a 350HS antenna. It was collected on the Surf 4000 with an older version of the software that didn't quite write the antenna type correctly. So that's why it has such a strange name. But it has a center frequency of 350 megahertz. The default high-pass, low-pass filters that we use set the low-pass at 1000 and the high-pass at 100. You can also do, usually I do 700 and 100 if I'm doing it myself, doubling the center frequency for the low-pass filter. And then even though a quarter of 350 isn't 100 is pretty close to the bottom edge of it. So that's a good number to use for your high pass filter. Remember to also take a look at the scope as you make these changes to see if you might need to tweak those values a little bit more. Might be worth applying again after a range gain just to see if there's any more changes we need to do. It's a little rough up there, so try just going up a little bit more. The second thing I wanted to note about this too is this is a pretty large grid, especially compared to the first one that we did. There is a trick to speeding up processes in RADAN, and it's very counterintuitive. RADAN will process your grid faster the smaller this window is. So it will technically process your grid the fastest when you minimize the entire RADAN window. What I usually do is I open the tables pane and the file header, and I just make them really big to make this window as small as possible. And you will find that your processes, that green bar at the bottom, is going to fly by when you make this window very, very small. So if I ever open these windows and they look tremendous, it's because I was doing some processing. Right, so this bar is filling up pretty slowly, and then if I head over to home, I open up the tables pane and the file header, notice how much faster it's filling. And especially for range gain and migration, don't forget to scroll through a few of your files before you hit the OK button to make sure that the range gain curve you're making and the migration that you're applying is representative of most of your data, that you're not overdoing it anywhere. Okay. Then we are going to head to the 3D view. If you click on 3D view, oh, my Windows settings pane is huge. I see. And I'm looking at my grid in GPS coordinates right now, which I usually don't like. It generally distorts my features. So instead of looking at it in this way, I'm going to close my 3D view. I'm going to head over to view, and I'm going to switch my coordinates from GPS to local. I'd recommend doing it here without your grid open. So we're going to head back over to home and try 3D view again. Okay, and that gets us all right. So we have our grid open. We have our 3D volume options pane open. I am going to stretch out the Z scale by holding Z and pressing the up arrow a few times. Okay, going to move my walls to the far end. And looking at this, I'm remembering now that this was a grid collected moving in one direction. So we went up and down along the y-axis, which means that this profile is real and this is fake. We did not collect any data moving in this direction. So when that's the case, I usually try to hide that because I don't want to make any interpretations off of this. So I can go over here to XYZ visibility and usually mix this up. Yep. All right. So I'm going to hide the Y over here. Yeah, RADAN thinks that these are X profiles, even though we were moving up and down along the Y axis here, and these would be the Y profiles. So I'm going to hide the Y data and show the X data. Even though these were files in Y direction. So it's a little confusing, but looking at this data, I know this is the one that I want to see, so I'm just going to hide whichever one keeps this on the screen. Okay. And then I can slice up and down through this. And this, here in the middle, this was the intention for this grid, was to locate this particular layered feature here. So I'm going to add a little bit of extra display gain to make this brighter and easier to see. And then as I slice through this profile, I should see that this layer here, yeah, it's pretty nicely visible. This little dipping layer here, it's pretty nicely visible as I slice through this grid. So the intention for this, if you couldn't tell by the name of the folder, this was collected at the Manchester Country Club, ManchesterCC. And the intention for this grid was to locate an old sand trap on the golf course using some historical photos of it to pinpoint where this grid should be. And as we can see this trap here, we can close all of these currently open files, and we're going to move on to our next grid. So again, easiest way to do this is to click on the main button, click on close all open files, clear out your working space, And this will allow us to, one, change our source directory, and two, start assembling a new grid. So we're going to head back over to global settings, and we're going to head over to our source directory. We are going to go to the cemeteries folder. So we're going to head over to cemeteries. And now we're going to take a look at a more complex 3D grid setup. So 3D batch of files is really good if we have a fairly simple 3D area. We're using a square rectangular area with no real obstacles in the way. But if we have a more complex site that might have trees or obstacles, and we need to add maybe segments to our grid or rotate some of our profiles around, that's a better call, not for 3D batch of files, but for 3D file. So this time we're going to assemble a 3D file, not a 3D batch of files. So we're going to head up here to the cemeteries folder. We're going to head to the Edgewood grids 1 and 2 folder. And we are going to highlight the grid 1 folder. So in the grid 1 folder, you're going to see that there are two different subfolders. There's a grid normal folder, and there's an add-on lines folder. This was done intentionally. We placed all of the files that started on the baseline in the grid normal folder, and we added all of our segments into the add-on lines folder. And again, this was done intentionally because we can tell RADAN, we can point to a specific folder and have it automatically load profiles from one folder and then add in segments that we keep in some other section after the fact. It might make some more sense as we start going through the assembly procedures. So we're going to start assembling this grid. And if there are any questions after the assembly process, it might be better to maybe just let me know them after the fact. So we're going to highlight this grid 1 folder as our source directory because we can point to other locations later on. We're going to highlight this and hit OK. I'm going to head into my folder here to see what units we're working in. You don't need to do this, but if you want to tag along, you can head into that Edgewood grids folder. There should be an Excel file in there that has all of our dimensions. And I'm seeing that this is in metric. So I want to, after I update my source directory, switch my horizontal units to meters. So the single M. And since my horizontal units are in meters, I usually like to keep my vertical units the same. You can have them in centimeters or meters. I'm going to do centimeters vertically and meters horizontally. And then we are ready to assemble. So head over to the G, head down to assemble data file, and we're going to do a 3D file assembly. All right. So on this first window here, all we need to do is specify the name of our grid. So we're going to give this a new name. I already called it Edgewood grid, so maybe I'll just call it my second grid. Hit save. There are 2 ribbons here for me to work under, files in X direction and files in Y direction. Looking at my Edgewood notes file, I see that all of these were collected in the X direction. This means I only need to fill out one of these 2 tabs. So we didn't do anything in the Y direction, so we're just going to highlight the files in X direction ribbon and only fill out things here. This started at 0, 0. Again, 9 times out of 10, that's going to be the case. We're starting at 0, 0. And looking at my notes, I see that the x-axis was 26 meters long and the y-axis 22.5 meters. I have 91 profiles, so I'm going to type in 91 profile lines, and notice the line spacing fills out automatically. The line spacing is set to 25 centimeters or 0.25 meters. So another thing to note here is this line order, the default line order is likely correct in our case. If you look at the notes, you'll see that in the additional details for grid 1, there are quite a few things we're going to need to change. Some of these profiles are going to need to be reversed. A reasoning stated afterwards. If you couldn't tell by the folder this is in, this is a cemetery survey, so we're looking for graves. There were some gravestones on the baseline for profiles 28, 29, and 30, so those will need to be reversed. There is a profile that's been deleted already. We don't need to worry about deleting profile 44, but there are also some profiles that ended early. We have some add-on lines, which are lines 38 and 40. Those are in a separate folder, the folder called add-on lines. So we will worry about those when we're adding segments. There are some profiles that need to be reversed. Profiles 92 to 97 will all need to be reversed. So we'll do that after the fact, but beyond those reversed profiles, this is telling me that everything else started at 0. So that means this default line order here is correct. The black box is in the bottom left-hand corner, which best practices for RADAN, that is where you want your starting point to be. So that is correct for here. We started at the left and worked our way to the right, starting at 0 and worked our way to 28 meters because these files were in the X direction. Profile spacing is okay. So all we have now working our way down is the working folder and this auto load files checkbox. So this is going to save us a ton of work in the assembly process. We're going to update our working folder to the grid normal folder. And then we're going to hit OK. So once I hit OK, again, only in the X direction, not in the Y direction. Once I hit OK, we're going to see that RADAN will grab those 91 files and put them in the right location for us, saving us from having to do this manually. So this means all that we need to do is reverse the profiles that need reversing and then add the add-on lines that are specified in our grid notes. So I'm going to make this window a little bit bigger so that it's easy for us to see. Specifically, I want to make this bigger and these smaller. so that I can see my coordinates and I can see my file names. And you'll see as we highlight over different files here, if you click on one of these and you move around and hover over one of them, you'll see that the name of the file shows itself. Right, so right now my mouse is over Edgewood 22, which is this red line right here. I can see the coordinates of Edgewood 22. If I want to make any changes to this file, I can double click on it and I can give it new starting and ending coordinates. I can even skip a distance. I rarely use this, but if you, for some reason, want to say I started at 0, but really you started 5 meters from 0, instead of typing in 5 meters here, you can just say I want to skip 5 meters and it'll do the same thing. So I usually just leave this set to 0 and type in the actual coordinates, but if you want to be fancy with it, you can do this. I'll hit cancel because we're not changing anything about file 22, but this is why we put our add-on lines in one folder and all of our other files in another folder, so that RADAN can grab them automatically and put most of them in the right location. So this saves us a lot of manually adding files, a lot of manual additions. So all that's left for us here is to go into our notes and reverse the profiles that need reversing. If you are running tight on screen space, don't worry about doing this. I will tell you which ones that need reversing. So looking at my notes, I see that we need to reverse profiles 28, 29, and 30. So we're going to go over here in our file name list, and we're going to look for Edgewood 28, 29, and 30. And we're going to want to reverse these. So I'm going to double click on Edgewood 28. I want to reverse this. It says that we started at, so SOL is short for start of line. Start of line is y equals 5.25. This is just being extra careful, saying that yes, this does, file 28 does start at 5.25, so we're on the right line. We didn't start at 0, we started at x equals 26. So type in 26 there, and the file length is 25.96. So 26 minus that is 0.04. So we started at 26 and we ended at 0.04 or 0.04. If you missed the first 0, that's okay. Just typing in 0.04 is fine. We can hit OK. And if you look very carefully on this grid after we hit OK, you should see that one of these arrowheads is now going to be pointing to the left. So that means we did it right. We reversed the profile. Now, instead of starting at 0 and going to the right, we are starting at 26 meters and going to the left. Less an error and more so, the reason why we reversed it in the first place is that there was a gravestone at the baseline. So we collected as much data as we could up to that point. But part of it can be attributed to a small error in the survey wheel potentially, but also that there was something in the way. So we collected as much data as we could up to it. So next we're going to do file 29. File 29 we also need to reverse. So we're going to double click on Edgewood 29. This also started at 26. I see that the file length is 25.88, so 26 minus that is 0.12. and then we'll hit OK. And again, we'll see that it flips around and the arrow is now going to the left instead of the right. One more, Edgewood 30 needs to be reversed. So we start at 26 and end at 26 minus the file length, which is also that, so 0.06. All right, so we've reversed 3 profiles, 28, 29, and 30. Since we're already reversing profiles, I'm going to skip over adding the add-on lines at this point and then move over to reversing profiles 92 to 97. And then we'll go back and add on those lines after the fact. Doesn't really matter which order we do these in, as long as we do all of them before we hit the OK button here. Yeah, so the documentation is in the Edgewood Notes Grids 1-2 file that is in the Edgewood Grid folder. So if you go into cemeteries, you go into the RADAN class datasets, you go into the cemeteries folder, and then you go into the Edgewood Grids 1 and 2 folder. There's going to be an Excel document with all of this information here. Everything that I'm doing here, I'm reading off of notes that were made when this grid was collected. So if you are doing this for a grid that you collected, this is a clear case for taking good notes. You need to have some notes on why you're doing these things or why you collected them this way, so that when you go to build it, you build it correctly. So if you look in this Excel file, you'll see all of the things that are made note of here. We're making note of the dimensions, right? Very critical. You need to know how long these lines are. We're making note of which files are in this grid, files 7 to 100, how many profiles there are, 91, how many add-on lines there are, files 38 and 40 are the add-on lines, and then which ones need reversing. It also helps to know why you're reversing them. Not critical, but it does say that there was a gravestone. That's why we reversed these 3. We're specifying which y-axis we're starting them on. We're specifying which ones ended early. 37 ended early, and 38 is the add-on line. 37 was cut short because it ended at a tree. 38 started at the tree and it ended at 26 meters. 39 ended at another tree, and 40 started at the tree and ended at 26 meters. 44 we deleted, and then 92 to 97 we're reversing. Doesn't say why, but it does say that it started at 26 and it goes from 26 towards 0. All things worth taking note of when you're doing these more complex grids. And if you're building a more complex grid, building it in the 3D file assembly will make this process much easier. So we're going down here, we're going to reverse the last few profiles before we add on the extra lines. Profiles 92 to 97 need reversing as well. So if you scroll down to Edgewood 92, we're going to start here and we're going to reverse from 92 to 97. I'll double click on Edgewood 92. I see that it started at not 0, but 26. The file length is 24.74, so 26 minus that is 1.26. 1.26. I hit OK, and I did that right. Yep, I hit OK. '93 we do next. Started at 26 and ended at 1.86. Okay. Same thing over here. Started at 26 and ended at 1.86. Started at 26, ended at 1.76. 96, started at 26 and ended at 1.96. And lastly, 97. 97's easy. Started at 26. It's exactly 26 meters long, so that means we ended at 0. All right, so we reversed profiles 92 to 97. So we've, looking at the notes, reversed all of the profiles that need reversing. So all that's left are adding the extra 2 lines, profiles 38 and profiles 40. So you should see a button at the very top of the screen, Add File. Let's click that. That seems like that's the one we want, right? We're going to go to the File Name window. We're currently in the Grid Normal folder, which means we need to go up a folder, which we can do by clicking this button here with a green arrow pointing up. And then we want to go to the Add-on Lines folder. So we'll just double click on that. And in the Add-on Lines folder, we have 2 options, 38 and 40. Let's do 38 first. So I'll double click on 38. Looking at my notes, I see that it's consistent along y equals 7.5 meters. So we started at y equals 7.5 and we ended at y equals 7.5. Remember, these values are the same for profiles that move along the x-axis. Y stays the same, but x is going to change. X ends at 26 meters, so I can type that one in. And all that's left for me is to figure out where we started. Well, I know it ends at 26 meters. I know that the file is 8.36 meters long, so I can just take 26 minus that and get my starting coordinate, which should be 17.64. Did I do that right? 64. Yes, okay. So 17.64. We'll hit OK. And you should see a dark blue line show up parallel to the one right before it. Should be Edgewood 37, this one right here, and Edgewood 38. This one right here. All right. So there's only one more left. The last one, add file. We'll hit file name. We're again going up one level, hitting this green arrow, add on lines, and Edgewood 40. All right, so this one was consistent at y equals 7.75 meters. So 7.75 ends at 7.75, ends at x equals 26 meters. The file length is 8.24 meters. So I'm working my way from right to left. If you'd rather work left to right, that's fine too. But I know these two are the same. I know that it ends at 26 meters. I know that the file is 8.24 meters long. So that means I started at 17.76. I hit OK. Edgewood 40 gets tossed down here. I see this blue line shows up over here, parallel to the one before it. So at this point, I think we've added and changed everything that we needed to change. Our whole grid has been built. This blank space is here for the tree. I have these arrows pointing to the left. I have these 3 arrows pointing to the left. Everything else is pointing to the right. So if you scroll through here, you should not see anything called Edgewood 44. So that file has already been gone. But always good to double check. If you look at your notes, it does say profile 44 should be deleted. And if we scroll through Edgewood, we should not see anything called Edgewood 44. So we are good on that front. But if everything looks good, then we are okay to, well, hit OK. So we'll do that. And our grid will start to assemble. All right. So at this point, we have assembled our grid. This is the biggest grid that we've made yet. It's 91 profiles, or rather, I think it's 93. 91 started on the baselines, and then we added 2 add-on lines. So we have 93 profiles to process now, all assembled in one grid. This is a grid that was made in a cemetery. So this is a soils data set. If we look at the file header, we'll see that this was collected on a SIR 4000 with the 350 HS antenna. And if we look at the processing history, we'll see that nothing's been done to it, save for a slight position correction, which is that time zero correction. Time zero is not something we need to do here. So time zero has already been taken care of. We do see this slightly blurry positive line down here. This may be from a shallow layer in the near surface, but this should not be taken as our direct wave. We do not need to do a time zero correction here with SIR 4000 data. So everything else, though, does need to occur. So this includes our high pass, low pass filter. This might include a background removal filter, which, looking at this line up here, is probably worth doing. This also includes some form of time variable gain. We can do range gain if you want to try adaptive gain. That might also be a good candidate. Make sure whichever one you do that you test it on some of these profiles and not just the one that you're working off of. We want to make sure that if we do range gain or adaptive gain, that it works well on all of our files, not just the one we're working on. And same goes for migration. Because we're doing a grave site survey, we're not going to have any nice well-defined hyperbolas, but as we cross over our grave shafts, we're still going to have a tail as we approach it and a tail as we move away from it. Basically a diagonal line that gets shallower as we approach the grave shaft and then gets deeper as we move away from it. For that reason, because we still have these tails, we would still want to perform a migration that migrates or collapses these tails, which will make the grave shafts look more defined and the grid look better when we're finally looking at it. So definitely worth performing a migration here, and seeing if we can collapse those tails and not have them point up or down. So we're going to want to just type in different dielectric constants. We can try doing a fit, but it might be easier to just type in numbers, hit apply, hit reset, and see if we can get those tails to collapse and not point up or down. Remember, if they point up, we need to move the dielectric constant up. If they point down after hitting apply, we need to move the dielectric constant down. So we have a game plan. We know what the general goal of this grid is, so all that's left is to process it. This is a big grid, so make sure after you run the process by hitting the OK button that you expand the tables pane and you expand the file header to make this data window smaller and speed up your processes. I'm going to just get them ready to go and start processing myself. I encourage you to do the same if you haven't already. So we're just going to go through, process this grid. Once you point to your working folder as grid normal, then specify that you want to auto load the files. It'll grab all 91 of them, put them in the right location, and then all you should need to do is reverse the 3 that need reversing, and then, well, the 10, I think, that need reversing, 28, 29, and 30, and then 92 to 97. That should save you a lot of time. Okay, so at this point, our grid should be pretty close to processed. So we're going to head over here. I'm going to close the tables pane, and I'm going to close processes, and I'm going to open the 3D view data window. And with 3D view open, I'm going to close window settings as well. With 3D view open, and by expanding the Z slice or the Z scale, maybe I want to add a little bit to display gain to brighten this up. I usually find I need to, 6 or 12 decibels is usually good. We can start slicing up and down through this, and we should start to see some pretty well-defined graves here. Right, so these rectangular features here are the grave shafts that we were trying to locate. Dependent on how your migration went, these shafts might look well defined. They might start to bleed together a little bit. The goal for this migration was to remove those tails, which usually overlap with graves that are very close together. And it might start to make these graves look more like more consistent. They might start to bleed together without doing a migration, or by doing a migration that still has tails on them. These tails might overlap, and they might start to make the graves look like they blend together. So we might be seeing like where the shafts were dug a little bit shallower. That might be where these re-reflections are coming from. But I think where they all look very well defined and clear, that's where the graves are actually located. We can try to confirm that too by looking at so this is fake, this is real. So I can go over to my window settings, because right, we only went in one direction. So I want this to go away. And if I think it's the Y line, that means I want to do the opposite of what I think. Yep, cool. So that would be the X line. I want to hide. I can bring these in. And if I look here, I can see, these individual features. These are the grave shafts. I see some are a little shallower as well. That's, these other things up here that we thought were graves. But it's likely just these are only what, 50, no, less than that, 22, 23 centimeters down. So not terribly deep. So this is likely just maybe where some of the dirt was packed down more so, or we might just be seeing where the start of the shaft was when it was first dug. But I think where the grave itself is located, it would make more sense for it to be at least half a meter down or so. So that's what, a couple of feet, 1.5 feet down. We're going to get started up with some more 3D assembly now. To recap what we've done so far, we've worked with 3 separate grids up until this point. We started with a pre-assembled grid collected in one of our 3D data collection modes. And then we moved into a grid that we were assembling ourselves. We started with 3D batch of files These are for simpler areas where you have a square or rectangular space with no real obstacles in the way. You can do some minor profile adjustments on that last window where you look over the coordinates of each profile. So you can rotate some profiles if needed or change the coordinates of them if you need to. But it's a lot easier to do all of that in the second assembly method we discussed, which is 3D file. 3D file is generally recommended if you have more complex areas. In our example, we had to rotate a couple, or rather reverse a few of our profiles, and add sections to profiles that had obstacles in the way. 3D file is the preferred way to do this. So for your more complex sites, this is the recommended method to use. But let's say we want to take this a step further. Let's say we have a particularly large site that we want to survey using multiple 3D grids. And after those 3D grids were collected and assembled, we decided we wanted to view all of those grids at the same time. You can open multiple RADAN windows and look at them in each successive window to view them all, quote unquote, simultaneously. You can also open all of those grids and just toggle between the tabs to view each one in 3D. Again, viewing them, quote, simultaneously. But there is another way to do this using the Super 3D assembly. Super 3D is ideal if you know a common origin point for all of the grids you want to view together. Let's say you know how far away each grid is from grid 1. You can build all those grids and then use the Super 3D function to specify where each of the additional grids start with respect to grid 1, we'll say. This allows you to view them all at the same time, and even what we're going to do here is process them all at the same time. So to guide you through what we're going to do next, we are going to take 3 grids. They're currently disassembled, so they don't have any blueprint, any B3D or BZX file. We're going to take these 3 grids, we're going to assemble them into their grids, and then we're going to take these 3 grids and put them together into a Super 3D grid. So we'll be doing a grand total of 4 assemblies, 3 for each grid, and then 1 for the Super. And then once we create the Super 3D grid, we are going to process all 3 of them simultaneously to get them ready to look at in 3D. To get us started, we're going to head over to RADAN 7. So if you haven't yet, please close all of the files that you had opened earlier. We're going to need to change our source directory, and we're also going to need to change our units potentially. I need to double check and see what units we're working with this time. Okay. So I have my grid notes open. We are in meters again. So we're going to open up the global settings other window. Mine's extra big for processing, and I'm going to look over here and first change the source directory. So we're going to double click on this. We're going back into the cemeteries folder, but instead of Edgewood grids, we're going to do cemetery in wet clay. And to make this easier, I'm just going to highlight this one. I'm going to highlight this folder. I'm going to call this the source directory. And then as we're going through and assembling our grids, we're just going to point to these folders during the assembly process. You can also update your source directory in between each assembly. That's fine as well. But to save from us doing this a lot, I'm going to just say this is the source directory, which means we have a proc folder. We will have a proc folder in here eventually. You will not, because you haven't processed anything in here yet. So you should just see in the cemetery and wet clay folder 3 additional folders: grid 1, grid 2, and grid 3. Highlight this one and click OK. We are working in metric, so make sure at the very least your horizontal units are set to meters. I'm going to leave my vertical in centimeters. Less important here, but this is the one that really matters. Make sure you're in meters. And once we've done all that, we are okay to continue. So head over to the G button. And then we're going to go down to Assemble Data File. And we are going to choose, because this is a fairly straightforward grid without any obstacles in the way, we're going to choose 3D batch of files. So in this next window here, RADAN's going to ask where the folder containing the files we want to batch together are. We are going to browse to our first grid, grid 1, and then hit OK. We're then going to specify a batch file name. So we can call this whatever we want. Call it first batch. Then we'll hit next. So if you updated your directory correctly, you should see all of these files here from Mount Hope Cemetery file 5 to 24. We are just going to add all of these files. If you had opened up the grid parameters PDF, you'll see that all of these profiles moved in the same direction. So this is another unidirectional 3D grid. For this reason, the order here does matter. Now, fortunately, it should already be in the correct order. You want to make sure your files are in ascending order. File 5 was the first one, and file 24 was the last one. So just make sure that this is, in fact, in ascending order, and it is, so we can hit next. Next is going to ask for the dimensions of our grid. We're starting at 0, 0, so no need to update there. But our max X is, looking at the notes, 9 meters, and max Y, 30 meters. Files are only grouped in the Y direction, so we only went up and down along the Y axis here. Check off that box, and then hit next. Use entire 3D display, so we're good there. Specify the order. The default order is correct, so we are also good there. Hit next. We can quickly look over the coordinates to make sure that these are correct, and they all look fine to me. 50 centimeter profile spacing, which is what we have, roughly 30 meters long, which is also what we have. I said earlier, if you do need to make any adjustments to these, you can double click on the file name to change the starting ending coordinates anywhere. We don't need to do this for any of these, but it is possible to reverse profiles if you need to, or adjust the coordinates if you need to, but we don't need to do any of that here. We'll just hit next. We have the option of adding GPS coordinates like we did before. I don't have coordinates for this one, so we're not going to do it this time around, but this is where you could do it if needed. And then we'll just hit finish. Okay, so that gets us grid 1. We've assembled grid 1. Now we can move on to the next one. To assemble an additional grid, we can't have any files open. So remember, we're going to do all of our post-processing once we assemble these 3 into a super 3D grid. So I'm just going to click on the X here to close this out, and then we're going to do grid 2. So we'll head back up to the G, down to assemble data file, 3D batch of files, browse for grid 2, hit OK, and then we'll give it a name. We can add all of the files, should be just like before. We click add all, files 25 to 43, so we can hit next. We can specify the dimensions, same size as the earlier one. It is a 9 by 30 meter grid. Files grouped in the Y direction. And then hit next. Nothing to change here, and nothing to change here. Next. Everything looks good. They're all about 30 meters long, still 50 centimeter profile spacing, so We can hit next, no coordinates, and finish. Okay, 2/3 of the way there. So one more grid to go. I'll click X there to close it out because we need to assemble our last grid. Assemble data file, 3D batch of files, browse for a new folder, grid 3, give it a name, add all, scrolling through just making sure it's all in ascending order, and it is. And this is just me being extra careful. I've never had it add incorrectly, but it doesn't hurt to just give it a quick look. I hit next. Max X is 8.5 meters in this case, not 9. So make sure that you type in 8.5. Max Y is still 30. This is going to be a tall grid. Files grouped in Y direction. Hit next. Nothing to change here anywhere. Hit next. Scroll through, just make sure everything looks okay. A couple short profiles, but for the most part, everything's about 30 meters long, 50 centimeter profile spacing. Next and finish. All right. So we've assembled our 3 smaller grids, our 3 individual grids. And now to group all this together, we're going to talk about our new assembly function, Super 3D. So I'm going to close this out here. I'm going to head up to the G, assemble data file, Super 3D file. All right. So this time we need to give it a name, just like before. Just create Super 3D file, assemble file. Give it a name. I'll call it new super grid. Caps really matters. We'll hit save. Okay. Now we should see a window that looks kind of familiar. We saw this earlier with the 3D file assembly. Same add file, coordinates, file name, but nothing down here because we need to, instead of adding individual files, we are now going to add individual grids. And then as we start building our Super 3D, we will see the dimensions of that grid here. By default, it gives us a 10 by 10 meter square. So let's type in the actual coordinates now. We're going to click Add File. It's going to give you a little warning, letting you know that when you create this Super 3D, it's important that all of these grids have these parameters in common. So this is maybe an important thing to take note of. This is something that you intend to do in the future. To make this as easy as possible, I would recommend making sure that you use the exact same antenna with the exact same setup if you intend to create this Super 3D grid. You want the same scan density, that's scans per meter. You want the same time range, which is essentially depth range. Right, so one of your grids can't be looking down 100 nanoseconds, which might be 15 or 20 feet. And the other grid next to it can't be looking down 50 nanoseconds, which could be 6 to 10 feet, right? So it depends on the dielectric constant, of course. But generally what this is saying is make sure that when you build your Super 3D that all of the values are similar. Same samples per scan, same scans per meter, same time range or depth of penetration. Bits per sample, that's more related to the control unit itself. So, for example, the SIR 3000 collects data at 16 bits per sample, and our SIR 4000 collects data at 32 bits per sample. So this means you cannot create a Super 3D with SIR 3000 and SIR 4000 based data. Number of channels corresponds to the actual antenna. So this is just some terminology, really, but a channel is one transmit-receive pair. So 99% of our antennas are single channel systems. We do have a dual frequency antenna, which can transmit and receive at 2 different center frequencies because there are 2 sets of bow ties inside. This would be a 2-channel system because there are 2 transmitters and 2 receivers. Just a word on the warning. Make sure everything's the same if you intend to do this, and then click OK. And then it's just going to ask for the name of the file. We're going to click on File Name, and we are going to go into Grid 1. You should have a BZX file there. It has the same G icon next to it. Should be whatever you called it. I've done this a couple times, which is why I have 2. I'm going to select the one I did today, first batch. Notice by default, the ending coordinates fill out automatically, and the starting coordinates, we can type in whatever we want. If you have the grid parameters PDF open, you'll see that grid 1 is the first one. So we don't need to make any changes here for the starting coordinates. We don't need to do any rotations. We can just click OK. And after we hit OK, we have our first grid in place, right? So at this point, we haven't really done anything besides give our grid a different name. But now we're going to add our other 2 grids to it to start building our Super 3D out. So let's click Add File again. It's going to ask for a name. We want to go up 1 level. So we're going to hit that green arrow. We're going to go into Grid 2. And we're going to open the Grid 2 grid. How many times can I say grid in a sentence? Second batch is what we're going to select. Now this one we need to make some changes to. This one did not start at 0, 0. This one started 30 meters up on the y-axis. So the x starting value will remain 0, but y started not at 0, but 30 meters north of grid 1. Notice the ending coordinate updates automatically. No rotation needed here, so we can just click OK. And you should now see a second black arrow above your first one. Your boxes may or may not be different colors. Since I've updated RADAN, my boxes have both been yellow in this version. But historically, in older versions of RADAN, as you start adding grids, the grids will be different colored boxes, which makes it easier to see where they separate. So if yours don't look exactly like mine, that could just be because of the version you're running. And then lastly, we will want to add our final grid. So we're going to click Add File, File Name, up 1 level. We're going to go into Grid 3, and we're going to choose our last batch. Just like the earlier one, we still start at x equals 0, but instead of 30 meters, we are now 60 meters above the first grid. Type in 60 there for your starting y coordinate, no rotation. Click OK. And then we should have our last grid. I'm going to click OK at this point because we've now added our 3 grids. They're all in the right place. So we can click OK to finish our Super 3D assembly. All right. We have our Super 3D grid together. We can confirm this by opening the location data window and seeing that we now have 3 separate green squares. All of the lines are sort of cascading together, so we will be able to scroll through all of these here. I don't know exactly how many profiles this grid is made up of, but it's certainly made up of a lot. So all that's left for us to do is process this and get it ready for some viewing in 3D. This is a completely raw grid, as we can confirm by the file header. We can see that it says it was collected with a utility scan DF, and the antenna type is unavailable. I can tell you that this is also collected with a 350HS antenna. If you couldn't tell, we like using that for this. The 350HS, so this is a 350 megahertz antenna with no processing done to it. The only real process that's been done is time zero. So time zero, we do not need to worry about. All of the other processes we've been doing, we will likely need to redo here. This is a cemetery data set, so while we won't have pipe-like features, we do have features with tails, and they will represent better in 3D if we use a migration. We're going to go through this using the same processes we've been doing with our earlier grids. So I will leave you to the processing, and I'll touch base with you in about 10 minutes to talk about the final results here. This is a much larger grid too, so don't forget to add the tables pane and the file header to make this look a lot smaller before you run your process, or while you run your process, because it's going to speed things up a lot. Okay, so at this point we should be getting pretty close to a fully processed grid. The data should be a little bit more visible. I definitely would recommend doing a migration here because it can really help make these targets show up better. But once all that's complete, we can click on the 3D view data window and take a look at our super grid. So I'm going to make this a lot smaller. I'm going to keep it on though because I want window settings when I get to my 3D data window. And then we're going to scroll in over here. We're going to stretch this out a little bit by holding Z and pressing the up arrow a few times. The data that I really collected is over here, which moves up and down along the y-axis. So to hide these, I'm going to hit the, yeah, cool. All right, so I hide the Y data, leaving my profiles here. Okay, and now we have our grid. So some things you'll notice. I have three grids that are touching one another, but they all seem to be working separately, right? You can slice through any of them at any time, but they won't all move or slice together unless you head up here and use the buttons above. You can also type in specific depths here, and that will also lock all of them to the appropriate depth. But this is one way, the only real way to move them all at the same time. And we can see here that our graves appear to be about a meter or so down, which makes sense. You can, of course, type in a number here, not 100, just 1 would be fine. And that also brings everything to the right depth. I can pull my profiles in to confirm that. And you can see here that our grave shafts are right over here. There are these lines that we can see. Surprisingly clear for data in clay. A wet clay at that. But yeah. Overall, not too much different from what we've been doing already. We're just assembling multiple grids before creating our super grid instead of assembling and processing just the one. So there's just a few more steps involved here, but it's nothing unlike what we've already done.